Yeah. Hello. Good evening, everyone. Welcome. Is it audible? Can you please confirm? Or we'll wait for 2 minutes to join other. F- First, to confirm whether my that voice is audible.
It's very clear audible.
Sorry.
It's clear audible, sir.
Okay. 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 Thank you. Yeah. I think I will start now. If other will join, then we'll let them in. But my screen is visible, na?
Yes, sir.
Yes. Okay. Good evening, everyone. Uh, s- Welcome to the uh, live session for this that the 6th week for the course of statistic for biomedical engineer, and that will discuss the statistic and all. I am MD Asad Raja, PMRF scholar in the Department of Mechanical Engineering in Tiruchirappalli. And this is my biography about myself and all that we have already seen. So now we have seen in the coming in the last 5 weeks, like we like algo started, like how we have and till where we have uh, reached out. So if you see, to it's like in the first week we have seen that introduction to biostatistic. Then we have seen the application, where the application that when we are going to application in the uh, drug manufacturing or maybe biomedical instrumentation, or let's say if any patient came, so what is the patient uh, history and their mortality rate of the particular disease and all. And that the case we have seen in the first week session. Second week that we started to what is the statistic, like what is the need of a statistic and where it's going to help. And then after that we have like a fundamental aspect of the probability, like a probability also we have seen. And we have discussed the descriptive statistic also. Let's say when we talk about the statistic. Okay, before shall I proceed, any doubt is there till the last week? Like, hello? Like, before shall I go, like, any doubt and all are there so that I can clear first, then we'll go ahead with the lecture.
So now we go with the lecture. In between, if I doubt, I will ask, sir.
Yeah, sure. Okay, so in the second week, we have discussed what is the statistic and where it's going to be used, the statistic. Then we slowly jumped into what is the what are the things that fundamental aspect that we need, like what is that role of the probability. Then we have seen discuss of the discussion of descriptive statistic. Also, we have seen we have the what you can say mean, mode, median, also we have seen. And after that we have seen what is the probability theory we have seen, like we have discussed what is the what is the what is the conditional probability, then independent event, types of the event we have seen. Then we have seen what is the distributions. In the distribution we have seen continuous distribution. Then we have seen the discrete distributions. After that we have seen the expectation, because when we talk about the descriptor, so we were having mean, that's the median and mode. But to further extend that particular, so we have the expectation and then population variance and sample statistic. Then we have jumped to the inferential statistic. Before we have seen what are the things that need the probability. Then we jumped into the inference. Like before we've seen what is the probability that an event is going to happen. Then we jumped into. Then we have seen one that versatile theorem that we called a central limit theorem. After that, we have seen what is the confidence interval and what is the level of significance we have seen. Then we slowly introduce to the what is the hypothesis that testing. We have to hypothesis, like say we have some problems are there. So how it's going to proceed out. So that also we will be seeing. And after that, we have what are the element of the hypothesis. In that we have the null hypothesis, we have the alternative hypothesis, then we have the test statistic, that all was there. Then after we'll see for the large sample test, like it's will call the that the population is going to be normally distributed, and if it is going to be like more numbers of that the sample, and if we're going to come find some small number of samples, so that will tell that t-test, because that for t-test we have the conditions of normally distributed, and it should be the sample number should be less than of 30. Okay. Then we have checked what is the p-value. P-value is something that we have the confidence, that is the error of margin, we can say, like we have that much error we are allowing to the things, like it will go our in the favor of that null hypothesis and all. In the fifth week, we started with the what is sample, small sample test. Like in that also we were having single population, then the double population we have seen. Then we have seen type 1 error and type 2 error, and then we have discussed the relations also. What is the relation between, it's going to be like between from the type 1 to type 2, like it's going to be inversely proportional. If the type 1 error is going to increase, so type 2 is going to automatically decrease, because we know that we have the contingency table also there, like that possible outcome, and based upon that we are going to check about. Okay, then we have checked about power of the test. Power of the test is something that we have a probability chance, or the things will, like we are saying that much confidence, like that will going to happen, or like my like it's a 1 minus beta of that, like type 2 error. So it's something that certainly we are going to power, like confidence we are saying. So for the usually for the statistic application, that need to be 80%. But if it is more, then it is good for us. Then we have checked for the chi-square test. Chi-square test is something that we will be going to check for, when we don't want to go into the negative populations and all. So that we'll have to check it out. Then hypothesis testing usually variant that we have also checked. Then we have checked the contingency test, and then for that one probability plot. Probability plot we have seen, like what's happening, like when it's going to be toward the normal distribution. It means it's going to be like a straight line fit. So now today today's session we are going to start with like independent of two population. Then we'll check with the F
Sir,
and
excuse me, sir. Sorry.
yeah,
Sir, sorry for interference.
yeah.
Sir, this is a contingency test. Can you explain it more?
Yeah, yeah. Contingency table is something like I will explain. Contingency table is something, like it's going to be happen, like uh, what you can say, possible action is going to be uh, reality, and that's the test result. Okay. If it is H naught is true, H naught is false, is it? Then after, or either I'll take one more, like like true false case. Let's say fail to reject, or maybe we can say do not reject H naught. And second case, reject the H naught. So do not reject H naught, and H naught is true. It's going to be a correct. Okay.
Yes, sir.
Like it's going to be what is the reality. So we don't have to uh, reject it. And H naught is false, and we're not going to reject, like we have uh, rejected the null hypothesis also. Okay. So if what we in the test what we got, we have rejected the null hypothesis, but in the actual case, that is the null hypothesis was true. It means it happened like type 1 error. Okay. It's something rejecting the A true. So that will say type 1 error alpha. And second case, we have that H naught is false, but we didn't reject also. So in that case, what happened? Type 2 error. It's something failed to detect. Okay. So in that case, what happened? Rejecting a false null hypothesis. Okay, so it's a beta. Is it clear? Huh? Like something like contingency table, like we'll be having a that is that reality, and this is the test we have done. So now we have to check, like, because it's not is true. So we didn't going to reject the null hypothesis. So means it's a correct. Then that is H naught is false in the reality, and we also did not reject it. So in that case also true. But what happened in the reality, that the null hypothesis was true, but what we have done, we have rejected. So that will become the type 1 error. It's something that overestimating, we can say. Like we have done some sort of mistake. But H naught, in the second case, what we have, H naught is false, but the thing we didn't reject it. Like rejected a false null hypothesis. It's just the opposite of that case. So that error will say like it's a fail to detect. So that we will say like a type 2 error. Is it clear? Huh?
Yes, sir. Now it's clear. Thank
Yeah.
you, sir.
So I think till now we have discussed like a linear table. Then probability plot is something like, let's say we have UQ plot we are saying. If it is going to be like become 45 degree, so that will going to toward the normal distribution. And that detail we can find out in the lecture video. So whenever we'll see some question that going to be regarding to the probability plot. So if it is going to be some sort of variance, if it is not going to fit on the straight line, so that we will say it's not going to be toward the normal distribution. If it is going to be like a straight line, like it should fit the linear fit. So that case we'll say that going toward the normal distributions and all. Okay. So after that, now we have seen like we started the test. Just 1 minute. Hypothesis. So testing was there. So in that, what we have seen for the first, we have seen for the large sample. So what we have seen that the test statistic was something like z is equal to x minus mu upon sigma upon root under n. So based upon the central limit theorem. So here also it's something like we were not having the conditions like there should the that our distribution should be the normal or something, so that should be there. So central limit theorem, whenever the number of sample will going to increase, so it's going to be like in the case of it will go toward the normal distribution. So for the central limit theorem, we don't have that distribution, like it is not going to be necessary. It should be a normal distribution. So then the second case, what we were having first case, like let's say if we'll start with the a small sample, single population. A small sample, so that will comes under t-test. T-test like a student t distributions and all. So for that we were having assumptions like number of samples should be 30. It's going to be less than 30, and it should be normally distributed. I think I'm just giving the brief actually, so that I will start today like differences like going to be multivariate hypothesis, like it's we take some sort of two population and we'll check for the same population we'll do twice like before and after testing and all, so that will also check it out like two significance, the difference between the mean of the two sample we'll check it out. Then we'll check. We have for the last class the chi-square test was also there. So in that we have first we have checked for the independence of the test. Then now we'll check for the fit of the some fit. We'll check. So for that we were having contingency table was there. Then one formula was there, and that's going to remaining same procedure was there. After that we will move slowly. We'll going to forward. Okay. So before that, I will just give the brief like how it was there for the single population. I will take the extra page actually. So for the central limit theorem, n is equal to 30, it's like that we were not having any of what we can say uh, limitations and all. So now we'll come to the t-test. For t-test, we have to be less than 30 and it should be normal distribution. So what are the steps in the, what we can say, in any of the hypothesis testing? What was that? It is something will tell, start with the null hypothesis. Okay. So H naught is going to be a x is equal to mu. It's something, there is no much of that. Let's say I'm going to take any example if any diet is going to be effective or not. Simply I'm saying, so first what will be our assumptions or maybe status quo? It's like there is no differences are there. So what will the alternative hypothesis? What is the alternative hypothesis? Something will tell it, that will call two-tail test or greater than or less than, so it become one tail test. Okay. So what are the test statistic for this? T is equal to x minus mu upon sigma x, or sigma x something that was nothing, x bar minus mu upon sigma upon root under n. Okay. So these were the test statistic that will say T calculated or maybe the critical value. Okay. Then degree of freedom n minus 1. And if we talk about or maybe x minus mu upon s upon root under n, that s will become your x minus x bar whole square summation of into n minus 1. Then after for a level that going to will be level of significance something at that going to be a alpha by 2 degree of freedom n minus 1, we will get t tabulated, and based upon that we are going to tell like whether that test is having significant differences are there or not. So this we have discussed, and we have discussed now we'll start with the, and we have checked with the chi-square test also, but we'll solve some problem for the chi-square test also. Okay. So now we'll check for the statistical interference for the two sample. What will the two, what will be the two sample? In the two sample cases also, that the first cases will be having, let something, if both are having same sample variance. If it is not there, in that case, so how to get like appropriate number of sample size? Let's say if sample that going to be number of sample is same, so n is equal to z alpha by 2 upon expectation by 2 sigma 1 plus sigma 2 square. So this is the one case. And if it is not going to be a like what you can say sigma square sigma 1 square, like a sample variance is not going to be equal to that's going to that's going to that the sample variance of the second population. In that case, that will become your like t statistic, like someone t x minus x bar minus delta naught by s square by n1 plus is something all are same only, x1 minus x2 upon something will tell sigma square by n1 sigma square by n2, that we have seen in the previous class also. It's something the extension of that we'll see, and and that degree of freedom formula it will that will going to come like this. So now we'll solve like multi multivariate hypothesis sample test. So in that case, we will be having population 1, population 2, So from here, it will going to be mu1, mu2. We'll take some sample, it will become x1, bar or something, x2, and that should be less than of 30, less than 30. And n1 and n2, there is not what you can say, like it should not be same. That is not the case. Like either it can be different, either it can be same. There is that is not going to much of issue in that case. So for this, what with the assumption we have first population, second population variation should be same. Like means variance equal for both population. Okay, and the normality should be there. Normal distribution should be there. So this is the assumption. So for this case, what will be the null? What going to be a null hypothesis? In this case, it's going to be a mu of sample one is equal to mu of x2. Okay. So what will be the alternate hypothesis? H1 will become again two case. We'll say both doesn't have what do you say any differences are there, and either mu x1 greater than of mu x2 or mu of x1 less than that of x2. So this will become one tail test. Okay. So for that, what is the what is the test statistic? So I'll take one page actually. Okay. So test statistic will become t is equal to x1 minus x2 x2 bar of sigma x, or we'll say x1 minus x2, as we all know that both are having same like population variance. So n1 plus by n2, or either we can say simplify more, x1 minus x2 by s into n1 n2 n1 plus n2. Okay. So here s is going to be a combined standard deviation. What is the formula for that? We'll be having the formula of sigma of x1 minus x1 bar square plus summation of x1 x2 minus x2 bar whole square n1 plus n2 minus 2. So degree of freedom will become n1 plus n2 minus 2. Can anyone say like why it become n1 plus n2 minus 2? Anyone like any idea?
It's for two-tailed distribution.
Yeah, it's a two sample test. So we already calculated the mean. So now number of degree of freedom will become whatever we have total minus 2. Is it clear?
Yes, sir.
Yeah. So this will become T critical. Now T tabulated will get T of alpha by 2 degree of freedom. And if T tabulated less than of T calculated, so we are going to reject the null hypothesis. Otherwise, we'll say we don't have the enough evidence to uh, reject the null hypothesis. So based upon that, we'll try to solve one problem. Can you please just check? I think this problem we have solved last class or no? Either today we'll solve fully. So I think we have the n1 is equal to 12. Can you please tell like shall I solve or shall I go ahead and solve the chi-square test like fitness test and all? Hello?
We'll solve and we'll proceed.
Okay, I'll solve at least this question. Then we'll go to the next one. So and alternate will become because they are saying there is a difference is there or not, mean increase is there or not. So it will become two-tailed test. Okay. So now we'll go and try to get like let's say diet A. We have x1, x1 minus x1 bar. Then we can have x1 minus x2, no, x1 bar whole square. Can you just tell me what are the values are there? We have value of 25, 32, 30, 34. Then we have 24, 14. I'll continue. 32, 24, 30, 31, 35, 25. This one will become x1, x1 minus x1 bar, x1 minus x1 bar whole square. Okay. So just tell me what will be the value of x1 bar. A summation of 25, 32. It's the total of it's coming 3, 26 by 12 is equal to 28. And x2 we'll see later in the coming slide I'll take. So 28, 25 minus 28, it becomes minus 3, minus 4, minus 2, and it became 6, and minus 4, minus how much we have? Like 24 and 10. So minus 14, and we have 28, 4, then minus 4, 2, 3, 7, minus 3. This became 9, 16, 4, 6, 6, 36, 16, 196, 16, 16, 4, 9, 49, and this became 9. So now this summation of x1 minus x bar square, it became how much? 380. I have the value, so you can calculate. Okay, just do it till here. Then we'll go with the right B. Okay. Shall I go for the second right or shall I wait?
Yes, sir. Yes.
Shall I wait?
No, sir.
Okay, okay. Now we'll take right B. So this will be x2 minus x2 bar, x2 minus x2 bar whole square. Okay, so it will become 44, 34, 22, 10, 47, 31, 40. Then we have the 30. We have total 15 sample is there. 3, 4, 5, 6, 7, 8. Then 40, 30, 32, 15 is there. Then we have how much? 30, 32, 35. Then we have 18, 21, 35, 39, 22. So just tell me like what is some like x2 bar how much came. So if you do x2 bar summation of x2 by n2. So we have the value 450. You can do later. It's came 30. So this came how much? 14, 4 minus 8 minus 20. Then we have 17, 1, 10, 0, 2, 5. And we have minus 12, minus 6. No, minus 6, no, minus 9, 5, 9, 8. This becomes 64, 81, 25, 81, 144. Then become 25, 4, 0, 100, 1, 70, 72, 89. This become 400. This became how much? 64 and 16, 196. So this will come summation of x2 minus x2 bar, which came around 1410. Okay. So I think till here it's clear, na?
Yes, sir.
Nothing. Yeah, it's just a calculation actually. We'll take one more page and now we'll calculate S. S formula we have summation of x1 minus x1 bar plus summation of x2 minus x2 bar whole square n1 plus n2 minus 2. What the value? It came around how much? We have 380 plus 1410, 12 plus 15 minus like 12 minus 15 minus 2. How much it came? Degree of freedom will be n1 plus. It's actually 8.46. So now T statistic will take x1 minus x2 is actually a modulus actually. Whenever will be not going to be a like not going to be a negative value. N1 plus N2 by N1 plus N2. So if you calculate, we'll keep value N1 is we have 828 minus 30 S 8.46 12 into 15 12 plus 15. So it's going to be a T bar minus point of 610. Okay, so will be eventually 0.610. So at level of significance 5%, so T of 25 0.05, it will become 2.082. So means T tabulated greater than of T calculated. So we don't have enough evidence to reject the null hypothesis. So I think this part will be clear. Okay. So I'll go to the next part. So earlier, what we have discussed, it was going to be a like difference of mean of a two population. It's an unpaired test that are not paired. Now we'll discuss about to test the significance of difference between the mean of two population dependent sample, paired sample. What will be the example? Any idea for the paired sample?
Pre-test and post-test same for the same group.
Yeah, like let's say I'm going to measure performance parameter of athletes. What we'll do, we'll take before starting training, so we'll take pre, then training period, and it's going to be black box, then post. So for a one population, it's going to be pre and then post. So it's going to paired. So this is the one example for the paired sample test. But and other than that, we'll be having same going to be assumptions. It should be a number of samples should be less than 30, then it should be going to be a normal distributions in all. So in that case, N1 is equal to N2. It's going to be automatic pair, or it can be of it's going to be a less than 30. In this case, T of like test statistic will become T is equal to D upon S root under N, or D upon S root under N. So D is nothing, is actually a increment or decrement. It depends. X1 minus X2. We can take the mode. D1 is like D1 bar will become mean of increment. So sample S, what will become sample? S D minus D bar upon N minus 1. Everything is same. D minus D bar. Earlier we were having S is equal to X minus X1. What you can say? Bar whole square summation of into N minus 1. So now instead of that, now it will become D minus D1 bar square to the whole square by N minus 1. It's a simple case of will become simple population test will become. Okay. So in that case, null hypothesis will be same. It's something mu of x1 before and after training. There is no much of differences there. That will be our status quo, like something that we have to assume it. Then what will become the alternate hypothesis? Either there is a no, or will tell first training having more efficacy than second training, or first training have less than of efficacy of, so that one. So this became single tail test, and this became two tail test. So everything will be same. Now we'll solve some problem based on this. Like only one that problem will solve. Now we have an IQ test was administered to 5 people before and after they were trained. Some sort of training was there. So we have checked before the training and after the training of the 5 people whether there is any changes there or not. So now our agenda is to whether there is any change or not. So if something null hypothesis will become mu of x bar is equal to mu of x2. What will be the alternate hypothesis? Will become mu of x bar is not going to be a mu of x2 bar. So it's going to be a two-tailed case. Is it clear? Hmm. So now first IQ1, or we'll say x1, IQ2, x2 will calculate. That is given. B is equal to x1 minus x2. Then after we'll calculate d minus d bar. D minus d bar to the whole square. So first one we have 110, 120, 123, 132, 125. So for that we have 120, it got increased, but for this it got decrease, it got increase, again got increase, again got decrease. So by seeing itself, we can't comment on this. So what we'll do, we are going to calculate difference. 2 minus 2 minus 4, 4. So now summation of d will become 10. How much? 4 to 6. So it will become effectively minus 10. Okay. So what will be the d bar? Minus 10 upon 5 is become minus 2. So now d minus d bar. Minus 10 minus 2 minus, like, so it became minus 8. 2 minus minus 2. So it became 4. Minus 2 minus minus, so it becomes 0. Minus 4 minus 2, it become minus 2. 4 minus minus 2, it became 6. It says 64. It says 16. Just see how it came. We have a 10 minus minus 2. So effectively 10 plus 2. So it become 8. So like this it will go. I just applied the formula. 0, 4, 36. So now what is summation of d bar? It became 120. So now we'll take one page and we'll go ahead. Okay, so we have done calculated like summation of d bar is equal to 122. So what is the S will become summation of S minus b minus d bar whole square by n minus 1. 125 minus 1, 120 by 4, 230. It become 5.477. So what will be the t statistic now? T statistic will become d bar S upon root under n. D bar into root under n upon S minus 2. How much? 5. 5.477. What is the value? Point of 8165. So T came point of 8165. Okay. So degree of freedom 4 at 5% level of significance T4 0.05. It will become 4.06 if from the table. So T calculated less than of T tabulated. So we don't have enough evidence to reject the null hypothesis. Is it clear? Huh? Can you please tell, is it clear?
So
Hello?
here the degree of freedom,
Yeah, degree of
sir,
freedom.
degree of freedom,
Yeah, sorry, your voice is not audible
okay,
properly.
sir. Sir,
Degree of freedom will become n minus 1, na? Or any doubt is there? I think your that hello.
okay, clear, sir. Okay, sir.
Okay. When we have two different
Sir,
group.
it's clear. Okay, thank you,
Okay.
sir.
Okay.
Okay,
So I think we'll go ahead. Shall I go ahead?
yes, sir.
Okay. So similarly, one more question we have now. The thing is that a certain stimulus administered to each 12 patient resulted in a following increase in the blood pressure. It means instead of they have given the x1 x2, they gave directly what d. Is it? Then after, can it be concluded that stimulus will in general be accompanied by an increase in the blood pressure? Again, by when we're going to define the hypothesis, they are saying increase in the blood pressure or not. So first, let's say I will fix the null hypothesis. It's going to be a no difference, like there is no increment and all. What will be the alternate hypothesis? It become increase. Okay, so it become one tail test. Is it?
Yes, sir.
And D they have given. It's all B. Difference is given. 5, 2, 8, minus 1, 3, 0, minus 2, 1, 5, 0, 4, 5. Then we have 4, 6. From D minus D bar we can calculate. D minus D bar whole square we can calculate. How? D bar will get from how? Can you tell? D, D bar will come summation of D upon N. How much we have? N 12. And if we calculate 5 to 7, 7, 8, 15, 15 minus 1, 14, 14, 3, 7, 20, 5 to 8, 7 and 15, 15 minus 1, 14, 3, 17, minus 2, 15, 16, 21, total 31. Is it correct? Done?
Sir.
Yeah. So we have to calculate, we have to now 2.58. Correspondingly, we'll calculate 2.48 summation will become 6.15 minus 0.58. It will become 0.34. It become 5.348. This I have kept on the paper, so I'll just that going to write it here. 3, then minus 3.48, 12.82, and I'll just write minus 0.42, minus 2.58, 0.18, 20.98, because it become 4, then minus 1.58, it became 2.42, then 2.42, it become 5.88, minus 2.58, it became 6.60. Then the last one, 1.42, it became 2.02, and for the 4, it became 1.42, it became 2.02, for 6, 3.42, 11.69. I'll take one page. What was that? Summation of, it came around how much? 1.88. Okay. So now S will become summation of D minus D bar square to the whole square n minus 1. It became 1.5.88 upon 12 minus 1. It became 11. It came 3.1. So now test statistic will become what? D into root under n upon S 2.58 into right under 12 upon 3.1. It came 2.88, and it was the one tail test. I think we have defined it already. So at level of significance 5%, T of alpha by 2 and degree of freedom this much, it came how much? 1.796 from T table. So we calculated, actually we have it greater than of T tabulated, so we are going to reject the null hypothesis. Is it clear? Is it clear now? Shall I go ahead?
Yes, sir. Yes, sir. You can proceed, sir.
Yeah. So now we'll come to the chi-square distribution. Chi-square distribution we have seen already. Actually, it's actually for the variance, interval of the variance, and continuous distribution that is going to be asymmetric, and it depends on the degree of freedom. If the degree of freedom is going to be increased, in that case, it's going to be a like move toward normal distributions and all. So it's actually a like to compare a set of actual frequency with the expected frequency, like something that we are going to test how will a sample fit to a theoretical distribution is a goodness of fit. So the purpose of chi square will be either fitness of the test. Let's say a population is going to follow exponential distributions and all. So by using this test, we can check whether that is going to fit for that or not. Like I'll be showing in that in the null hypothesis, okay, that's going to fit for the exponential. But if you're going to calculate or do the testing, it's whether it's fitting or not. So something like this we have to tell. Okay. So in that case, what we will do, like they are going to do like we can see here, it not going to be a negative region. It's going to be always when we're going to expect something, something that should be a like positive outcome. If something will happen, either something more than zero, it will not going to be a negative expected frequency. Expected frequency will be the always something will come into the picture. Expected frequency, let's say for a binomial distribution, it's going to be ncx and p to the power x, q to the power n minus x. So it in the worst case, it will be 0 or 1, but it can't go beyond of like 0 means it can't go then negative value. Okay, then that region will become like a rejection region, and this will become the that you're going to be area under the curve. So area under the curve is always 1. We already know that whenever any probability distributions and anything are there, so it's going to be a like 1. And under the curve, the area under the curve between the 0 and x square will value will be the cumulative property. Okay. So it's going to be like from like this. It can flat like this either way, but it will not going to be in that case, it will not going to be happen. Any worst case and all. So for the chi-square test is actually a measure of the how far the observed count are from the expected count. Let's say I'm saying like a time waiting in a hospital, so it's going to follow the exponential distributions or maybe the Poisson distribution. So now actual data we are going to feed it and then we'll check how far from the expected or observed frequency. So for that t value or x square, the test statistic will become summation of observed minus expected square by expected square. Okay. So in that case, if it is going to be like sigma f n is equal to going to be more than 50, and this will going to be same always, and no expected frequency should be less than that of 5. Is this and a information about the parametric population, that means it's going to be a non-parametric or non-normal. By the definition itself, it is going to be asymmetric. Okay. So shall we fit? I think this we have checked for to this problem we have done na, in the last class, or shall I do again? Or we'll check for the binomial distributions. Okay, first I will do for a simple, but we can say simple problem. Then we'll go for the binomial. Then we'll go for the Poisson distribution, and then we'll go ahead for the F test. So actually, for that we have to make the contingency table. Contingency table is something. Let's say we have A, B, C, D. We'll take it here. So this will become row total. So A plus B, and it will become column total. So it will become A plus C, and this will become B plus T. And this summation should be same. It will come, we'll solve the problem. So let's say for the frequency, observed frequency, we have FO or FA, FB, FC, FD. So now expected frequency of E of A will become what? Row total corresponding to A into column total by grand total. I will take one page actually. I'll clearly I will explain. Okay. So let's say we have a observed frequency, then we have the expected frequency. So F A B C D. So expected of A it's going to be a like actually that expected. It's going to be a row total into column total upon grand total. So for E of A, it will become how much? It will become, this will become N. N will say grand total. So E of A will become, we have for corresponding to A, row total A plus B, column total A plus C. So it's going to be A plus B into A plus C upon N. E of B will become, we have the B, so it will become A plus B. Now column total, it will become B plus D. It will become A plus B, B plus D upon N. E of C will become, we'll check with that. C, we have, this will become, so it is a C plus D and this was A plus C. So C plus D into A plus C upon grand total. Then E plus D will become how much? We have D, C plus D plus B plus D. C plus D, B plus D upon grand total. So can we calculate like how come it will come? What will come for this researcher of X and Y? Then below average, that above average and genius. Tell me how will do it? This one.
Sir,
Or shall I go ahead
you
with the some?
explained, sir. I'm very sorry.
Sorry.
Yes, sir. This you go ahead. Sir, you go ahead with now what you have calculated.
Okay. Okay, 1 minute. I'll just check with the other problem. Maybe that I'll solve anyway, but I'll check with the first binomial distribution problem. Is it okay now? So in the binomial problem, sorry.
Okay, sir. I know
Uh,
the instruction.
anyway, time constraint is also there, so I'll just do it. Okay, a survey of 800 family with the 4 children each revealed the following distribution. So will in that case n will be going to be a 800. Okay, and they're saying like does this result with the hypothesis that males and females are equally probable? So when we have the males and equal, that male or female, either it's going to be like it's going to be a binomial distribution. How come? It's going to be like two event only. Either it can go, or maybe the probability is comparatively high. And if you're going to for the Poisson distribution, all in that case, probability will be low, but the number of sample will be high. Okay. So in that case, so now we'll check with the null hypothesis. What is the null hypothesis? It's going to be like probability of the probability of or may for male female both are equal. Okay. So H naught will become P is equal to Q is equal to half. So bulk will be the H. So P will not going to be this much. So that's going to be a, this is the null. This is going to be a alternate. So I'll take one page actually. So we know that P of x is equal to x is equal to ncx p to the power x q to the power n minus x. Is it? P of x is equal to x is will become 4cx. How come 4cx? Because we have the 4 number of girls in the family of 32. Then probability of getting like that's going to be male or female, it's going to be half and half. Is it? 1 by 2 n into 1 by 2 n minus x. So 4cx 1 by 2 of half 4. Is it? Here x will become 0, 1, 2, 3. How come? 0, 1, 2, 3, 4. If it is 4, then it's going to be like there only. So now can we calculate the expected frequency? Can you please tell me like is this clear na? Like how we're going to calculate 40x p to the power q p to the power x or q to the power n minus x. Is it okay na? So now we'll calculate E of x is equal to x n of x, probability of x is equal to x. So n is equal to 800, 4cx 1 to the power 4. So expected frequency will become 1 by 2 into 4 into 800. So it's became 54cx. So now we're going to calculate what? E is equal to x is equal to 0. 54c0 became 50. E is equal to x is equal to 1. How much it become? 54c1. It become 200. Ex is equal to 2. It became 54c2. It will come 300. Because 4c2 is like 4 into 3 by 2 into 4 into 3 by 2 into 1. E is equal to x is equal to 3. It will become 40c3. It will be how much? 4c1. 200. Clear? Is it clear? Clear? It is clear, na?
Sir, on the formula alone, can you once explain formula alone?
Okay. Uh, we all know that binomial distribution formula. It's going to be of ncx p to the power x q to the power n minus x. Is it? And they are saying, does this result with the hypothesis that the male and females are going to be equally probable? It means they are saying like in a family, either it can be a male, either it can be a female. So what is the p? Half of, let's say when you're going to toss the coin, it will become either head or tail. So probability of getting head is half, So tail is also going to be half. So now in the family also, now they're saying either it's going to male or female, is it? So it will become half half. So now n c x half of x and half of n. How many n we have? Four. Either it will going to be a zero boys, four girls, or one boys, three girls, two boys, two girls, three boys, one girls, four boys, zero girls. It's going to be a four, is it? Maximum of four.
Okay, sir. Now you proceed. I something I got.
Sorry.
Sir, now I got. Now you proceed up to that formula alone. I got some doubt. So now I got
Okay.
some idea.
Okay. So this become 4 minus x. So this will get cancelled out. So 1 by 2 into 4 will become. So now I'll take one more page and then I'll simply put into the, what you can say, formula. So now calculation of but we have x is equal to 0, 1, 2, 3, 4. For that, observed frequency, how much we have? 32, 178. Is it? Let's say for 0, we have 32. For number of boys have to be 0. Let's say it's going to be a 32. We'll take 178. Then what we have? 290 to 236, 64. 296, 236, 64. What about that? That we have calculated E of x is equal to 0 at f of e is equal to become 50. Then it came 200, 300, 200, and 50. So now what we calculate? Because we know that chi square is going to be summation of f e minus. Okay, that is the formula. Okay, so we'll calculate f of fe. Fo 32 minus 50. How much it came? Minus 18. It came minus 22. It's going to be a how much? 290. Yeah, sorry. No, it's going to 290. So minus 10. 236 plus 200. So it's going to be a 36 and 40. So FO minus FV square. So 324, 484, 100 and 290, 1296, 196. So now we'll calculate what? FO FE by square by FE. It's going to be a 324 by 50. How much it will come? I will give the value 6.48. Then 484 by 200. 484 by 200, it will come 2.42. 100 by 300, point 333. 1926 by 200, 6.48. Then 196 by 50, 3.92. Now summation will become summation of FO FV whole square upon FE. We're going to 6.48, 2.48, 8. It became 9, 9.33, 6.96, 15, 15.3. So it became 19.63. So now we'll calculate what? Degree of freedom. How much we have? Total 5 minus 4. So now we'll calculate x square of 0.05 at 4. It came 19 point. If we check at the chi-square table, let's say it came in 90.62. So from chi-square table, so chi-square calculated is going to be chi-square tabulated. So it's going to be a reject the null hypothesis. Is it clear? Hello.
Yes, sir. Clear, sir.
Okay. So now these things we have done for the binomial distribution. Similarly, can we do for what we can say Poisson distributions? Now, one thing we have to apply the formula what? Can you please tell? Instead of in the case of binomial, we have applied 4 n c x p to the power x q to the power n minus x. So for Poisson, it will become what? P of x is equal to x will become e to the power lambda to the power x by x factorial. Is it?
Uh, yes, sir.
So how will get the mean value? Can anyone tell? We have given the number of equine. So lambda value, how will get it? Summation of all by n. So we'll get summation of fx by f, number of frequency. So it will come, some value will come. After that, we're going to find out the expectation at x is equal to x. So let's say some lambda came. Is it? So will you
Sir.
able to do it or shall I do it? Shall I do it or will you able to do it?
One formula you solve and this one, sir. Simple
Okay,
one.
okay. So first task is to calculate the lambda because we know the formula we have e to the power minus lambda by lambda to the power x by x factorial. Is it? So it's going to be how much? I'll take one page and I'll give it to you. To get the mean means lambda, we know the formula of sigma of x by sigma of f. So fx will be f 36 into x how much? 0. 0 into 36 plus. Then we have 1 into 40 plus 2 into 19. Then we have 3 into 2. And then 4 into 0. Then we have 5 into 2 plus 6 into 1. Number of frequency, how much we have? 36. Total is 100. So 36 into 0, it become vanish. We were having 4 into 0. 4 into 0. So it's a 100 by 100. It become 1. So now what the formula will become? P of x is equal to lambda e to the power minus 1, 1 to the power x upon x factorial. Is it? Is it clear that formula of
Yes, sir.
mean?
Yes, sir. Yes,
Hmm.
sir.
So now this is this is going to be p. So what will be the expected value? E of x will become whatever the number we have into p of x is equal to lambda. So how much number we have? 100. 100. This one we have 100 into e to the power minus lambda into 1 to the power x. It will become either of 1 to the power anything. It will become 1 only. X factorial. Okay. So what will be the first value? X is equal to 0. First will be the x is equal to 0. Is it?
Yes, sir.
So I will go. I'll take one more page. E of x is equal to 0 will become how much? 100 into e to the power lambda minus 1 into 1 to the power 0 by 0 factorial. It will become 100 into e to the power minus 1. How much it will come? Somewhere 36.787. So we'll say 37. Is it clear? Now a is equal to x is equal to 1. So this one 1, this one 1. So 37 into, or we'll say 36.787 into 1 to the power something will come 1 only. And it's going to be like how much? Factorial. 1. Again, same value. A is equal to x is equal to 2. Because how much we have? Till 6. So similarly, we can get it now. Shall I do it? Shall I do it or uh, you can do it? Shall I do it or that that you can do?
We will do, sir.
Sorry.
We will do, sir. We understood, sir.
Okay. I think that after that, once you have done this thing, so again that you can make a table x like this x. Then you can make FO that we have to. Then we'll calculate the FE. Then you can calculate the FO minus FE. Then FO minus FE whole square. Similarly, the last you can make F1 minus Fe whole square upon Fe. So then do the summation. It will become chi-square test. Then level of significance at 5% and degree of freedom as we have how much? 6. 0, 1, 2, 3, 4, 5, 6. So it will become like this. Okay. N minus
Yes,
2.
sir.
So with this, I will go for the F test. F test.
Yes, sir.
F test is actually it's going to measure of the variance. Till now we have seen the mean population itself, or we have checked for the chi-square test to check the fitness of the any test. Is it?
Yes, sir.
So till now we have seen like this one only. So now in the fitness like F test, what we'll do, we'll going to check with the variance. Again, the things will question will come. Okay, why can't go for the ANOVA? Let's check for the F test. We should have the only two population, like two group. But for ANOVA, it can be of many, that number of groups can be, or many number of that the population can be. Okay, so actually ANOVA is an extension of what we can say F test actually. So F test will take population one. From there, sigma that's going to variance one. From will take sample one, and similar way from two population we have, and then we can do it. Is it? So for the F test, what is the statistic actually we have? Actually, the statistic we have, it's going to be a okay. So what is the objective of the test? To test the significance of the equality between the two population variants, like whether the if any of the two population we have, whether there is any variance is there or not, or to test significance of the equality among the three means. It's something that we're going to more discuss about what we can say of the variance instead of discussing on the mean. So what is the first step? First one to, so we are going to set the null hypothesis. Okay. Then after we are going to like it's going to be again. So in the case of what we can say t test, what we were seeing, it's going to be a like mean mu1 is equal to mu2, or alternate hypothesis mu1 is not going to be mu2. So this was the mean. But for F test, what we have to do the variance. Will not go, because just see, sometimes if the variance having more, it means error is more. But the thing is, the population, it's going to be more or less same, the same. So we can't directly judge based on the population mean and all. So we have to move forward, and we have to check the what is the variability. If the variability is going to be less, we have the chances of the error is going to be less. Okay. So in that case, we can check it out. So first one, we are going to check the null hypothesis. It's become sigma 1 square is equal to sigma 1 2 square, or the alternate will be like what are the that's going to be a real case. In that case, it's going to be like again what you can say, it's going to be in the case of either two tail test. If it is, we'll say whether we'll say okay, just simply we'll say the both the population variance is going to be a different, but we are not saying which one is more, which one is less. So if we are going to specify that one is more, so it will become one tail test. Okay, one tail test will become. Okay, so for that, now what we have, now we'll check with the hypothesis. So what is the F statistic? Okay, for the F statistic, now F is equal to S1 square by S2 square, or either S2 square by S1 square. So F statistic actually a greater variance by smaller variance. How we'll calculate the S? We all know that we have calculated for the case of what you can say, for the case of simple mean single population. We have done. Similarly, we'll do it here also. Summation of x1 minus x1 like a square into it's going to be a square already. So we don't have to keep the square root actually. So now based on that, we'll solve some problem. So in a test given to a group of students from a two normal population, the mark obtained were as follows. Group A have something, Group B is something. Examine at the 5% level of significance whether the population have the same variance or not. So whenever the talk will come about the variance, so means in that case, whatever do it, we have to go for the F test. Okay, I'll take actually one, what we can say, uh, page, or maybe I'll start with the group one. What is the X1 value? Or I'll take one page actually. I think we have taken already. We'll go ahead with this. Okay. So that what we have group A, X1, 8, that was the 18, 20, 36, 50, 49, 36, 34, 49. Group 2 was like this. So what was that? X1 we have done. X1 minus X bar. So first step we have to calculate the bar, like it's going to be a mean. Then we have calculated the x1 bar. Then we calculated the x1 minus x1 bar square. So we got some value. Then we have squared it. We got some value. So based upon that, we have to calculate the s1 square, not s. Don't get confused. Like we have to calculate in the case of t is equal to x1 minus mu upon sigma upon root under n, and that sigma will become, or this s will become root under same formula. So here we have to actually calculate the s1 square. So it's going to be summation of x1 minus x1 square by n minus 1. Because for each population we have the two samples are there. So for each sample we have the one degree of freedom n minus 1. Second, n2 minus 2, that's going to 1. So that we got 1 s1 square. Similarly, for the group B also, we were having x2, 29, 28, 26, 35, 30, 40, 46. Then we calculated the x2 bar, it came 34. Okay. After that, we calculated the x2 minus x2 bar square. Then we have taken summation, so it came 386. Then further we have calculated the s2 square. So it came by n2 minus 1. So 386 by 6, 64.33. So I think till here is it clear? So that S1 we got 141 and S2 we got 64.33. Is it clear till here?
Yes, sir.
So now what will go? We will go for what we can say test statistic. If if calculated, or it's that will become test statistic. So in the case of S1 square, S1 square by S2 square. So it was 141.75 by 64.33. So it came 2.22034. Okay. So this is your, what we can say, critical value. Now add 1 degree of freedom, second degree of freedom, and alpha by 2 two tail test. So it value is from F table. Shall I show the table, or either you can see that you can see the table? Hopefully you are able to see the table and all. So now what we'll do, like
Yes, sir. We
now,
are able to see,
sorry,
we are able to see now. We learned how to see the table.
yeah. So now if calculated is actually less than if tabulated. So we'll not say except, we're going to say we don't have enough evidence to reject the null hypothesis. I think this is clear now.
Yes, sir. Clear, sir.
Okay, so before starting to some problems and all, again, I think the same one we have already, S1 we have, S2 we have already, N1 we know already, N2 we know already. So we can get directly formula and then we can calculate it. So similar way, we can do it directly. I think there is no need to solve again because they are saying group A is going to be a more than group B. It means it's going to be a one tail test. Okay. So
Yes, sir.
this is similar question, but here we don't have to calculate the S1 square, S2 square already given. Okay. So S1 is given. So S1 square will become what? 9. S2 square, 2 square, 4. So now F is equal to 9 by 4, 2.25. And this is that N1, N2. Degree of freedom will become 15 and 8. This is came 2.25. F tabulated also came 5%, 15 and 8. It become. So we don't have enough evidence to reject the null hypothesis. Okay. Okay, so now we'll solve some problem like based upon what we have done, like sample t-test and all we have seen. So how we're going to proceed it and all. So can you just read it out question and then tell me what will be the answer actually? Just try to solve. Which of the following, which of the following statement is true about the two sample t-test for the means? Just tell me. I'll just wait for some time. It assume that two population have equal variances. It's not no, not always true now. It can be, it can't be, because when we are going to do it, like we have two cases. Once we have assumed there is a equal variance. Sometime like uh, that would not always okay. When we're going to talk two sample t test, it's going to be like equal variance, not mean. Assumption is actually a variance, not the mean. So this can't be the answer, is it? Is it?
Yes, sir.
It is used for the comparing the mean of two different population. Yeah, it's because we are taking two population, population one, population two. Then we are doing a mean. So this can be the answer. Okay, we're going to check again the third option. It requires the sample size to be equal. Is it correct or not? Just tell me. It not necessary. It can be. It can't be. Is it? So this can be answer. It assumes that population are non-normal. No, it's going to violate because when we're going to talk about t-test, it should be normal. Is it? I think this question is clear. Shall I go ahead?
Yes, sir. You can go ahead.
Sorry. The two
Yes, sir.
sample
It's
test.
clear, sir.
Okay, the two sample t-test is designed to compare whether the means of two independent groups are statistically different. It's going to mean, not the other things. Okay, now we have the another question we have in a paired t-test, which is the primary advantage compared to the unpaired t-test? Just tell me what will be the answer. It's going to uh, reduce the degree of freedom. It's mathematically because n minus 2 will come, but it's not going to be a main advantage, is it? So this can't be the again answer. It increase the sample size. No, it it that not going to increase. No, like when we have taken samples, it will be same. Okay, so that can't be the answer. It control for the variability between the subject. Is it correct? It's a inter-subject, inter-variability of the subject. So this option is correct. Is it?
Yes, sir.
They are going to focus only within the subject difference. Okay, secondary option can be like okay that thing between the population also that they will do, but main agenda will be to between the subject itself. It eliminate
Means in
that
the
the
sir, excuse me, sir. Is in the same group only we are meaning between subjects? Is it
yeah
the
yeah
same group we are meaning?
like for the same group only. Only thing that for it's going to be within the subject. We are not going to compare with one subject to the another subject within the subject pre post. Is it? So it's going to be a control the variability between the subject itself, not the what you can say intra subject. Okay,
Okay, sir.
for paired, it's going to be always within the subject. It will not go beyond of the subjects. Then the last option we have, it eliminates the need of random sampling. No, random sampling is still that we need because that we have to avoid the what? Bias and all. Is it? Is it?
Yes.
So now we'll go for the third question. So a paired test is going to actually use the same subject are measured twice. Means before and after treatment, it's going to match the pair. The primary advantage is that a subject acts as their own control, which removes the variability between the individuals. Okay, so we'll go next. Now the third question we have, which of the following is the key assumption of paired t-test? Can you tell? Which of the following is a key assumption of p-test test? Whenever we have something t-test, it should be normally distributed. Is it?
Yes, sir.
The two sample must have equal variance.
Yes, sir.
Is it correct?
Yes, sir.
It's actually for independent t-test, not for the paired one. Is it? Will we not having any sort of variances in that, na? Because the same participants are there, same
Yes.
population is there, is it?
Yes, sir.
So it's actually that must be the case of independent test, not for the
Therapist.
paired test. The sample are dependent. Is it dependent? But it's by design, not the assumption. It's because of design. It's not because of the assumptions. So that can't be the. It is not the assumption actually. It's a design. By design, it came. Is
Yes,
it?
sir. Yes,
The
sir.
and the sample size must be equal. It's again a design because of the designing of the paired test. It will become equal. So it's not the assumption actually. It will come automatic, but not an assumption. Hopefully, this is also going to be clear. So we'll go next question.
Yes, sir.
When we are going to compare the variances of two populations using an F test, what will be the null hypothesis? Just tell me. When the comparing the variances of the two populations using an F test, what will be the null hypothesis? First one, the population means are equal. So whenever we are going to for the F test is supposed to for the variance, is it? F test is actually a for variance.
Variance.
This can't be
Variance.
the option.
Variance.
The population variances are equal. Yeah, correct.
Ye- Yeah, correct.
Again, the mean can't. The sample variance are equal. Just think about that whether that statement is correct or not. Is it correct? Just think about
Yes,
that.
sir.
Can't be. Why? Whenever we are going to population, the variance will be the equal. Once we take the sample, it's a our statistic. So we will can't state our statistic or hypothesis in the like what you can say null hypothesis. So it can't be. So sample statistic only it's going to be a for the population because this is sample variance is actually in actual our actual case is there because
Ah, yeah.
we have the population for the population variance should be same. But when we took the sample, that is the things that we need to check it out now. So that can't be the null hypothesis now, is it?
Ah, yes, sir.
So this also can't be the answer. So now the F test is primarily used to whether two population have the same variance or not. So homogeneity of the variance, null hypothesis, alternative hypothesis will be something like this. Is it clear?
Ah, yes, sir.
So now in the context of multivariate hypothesis testing, what does the term multicollinearity refers to? Any idea? Like, shall I explain the what is the difference between the covariance and then correlation? Is it? What is the covariance?
So, because, for example, I can say that one disease can have multiple symptoms.
Hmm.
Is it that, sir?
Actually, the correlation is something will tell it's going to be interconnected between the variable. Is it? Let's say a is equal to ax plus by or y is equal to ax plus by. So that will comes as a correlation coefficient, like correlation. The covariance will be the two independent we have the variables we have independent and will tell what is the difference between the two sample and all. Not the that will not going to say two random variable. It's going to be like totally independent. Is it? Correlation is something that existing inter variability. Covariance is something we have the two independent groups are there. Then we'll check okay whether the that they have the variance like that they have the any differences are there or not. Something like we'll check it out. No, is it or no? Covariance of x and y. X is the is each going to be one population. and then y is going to be another population. But once we'll say y is equal to ax plus by, it means y is going to dependent on the x. But if you talk about the covariance of x, it's not going to be directly related, that not going to be directly related, but it's going to be somewhere related, but not going to be directly related, is it?
Yes, sir.
Covariance will going to tell how the variable will going to move together, and something correlation is something like it they're going to tell how it's going to be one vary with the another. So now we'll come to the multi-collinearity, the correlation between the independent variable. In context of multivariate hypothesis testing, what does that term multi-collinearity? What do you mean by collinear? Collinear is just something that's going to be on a same line, is it? The correlation between, so that correlation coefficient or correlation coefficient is not going to be covariance between the independent variable. So in multivariate hypothesis testing, multi-correlation that going to refer to the situation where two or more independent variables are highly correlated with the each other. It means we have that will be having two something going to be a like what do you say? Sorry, multi-collinearity. It's going to be tell about the correlation between the two independent variable. That will correct answer. The correlation between the independent variable it can't be why. It's going to be tell about the covariance. Okay. The interaction between the dependent and the independent variable, it's that we call interaction effect. Is it? Equality of the population mean will not tell about that. Something related to the, something related to the hypothesis testing. So that can't be. So the correlation between the independent and dependent variable. Okay. So I think this is clear, or shall I explain again?
Once again, sir, whether I am feeling the answer is interaction between independent and dependent variables. I'm not so clear with this answer.
Okay. Actually, multi-collinearity is something that will be having between the independent variable, and interaction is something like independent and dependent. They both are having some different context. Okay. Is it?
Yes, sir.
Not not with the not with the variance, or maybe the interaction effect is different. Once we'll go into like some statistical testing like in further in the ANOVA testing and all. So interaction different, that is different. But that is going to multivariate hypothesis testing. Multi-collinearity is something we're going to correlate. We'll not talk about the interaction different. Interaction different, and then correlatory and then covariance is totally three different meaning is there. Is it?
Yes, sir.
So interaction different is itself is a different parameter. It's not going to comes into the collinearity or correlation. I think hopefully that is clear now.
Yes, sir.
Okay, so now we'll go next question. We have, which test would you use the compare the means of three or more groups simultaneously? Just think about that. Two sample test. So that itself can't go, because two sample test is going to be like only two sample, but they are saying three or more group. We can't do na, is it? And pair T test also it will going to be like maximum two
Correct.
group. That can't be the answer. This can't be the answer. ANOVA. ANOVA is actually
No,
for multi group.
multi.
F test limitations only two group. Is it?
Yes,
I think C is the correct
yes, sir.
answer.
Correct.
Okay, so we'll go to the next. When we want to compare three or more groups, so we'll go with the ANOVA. ANOVA is actually
No.
between the among the group means,
So,
and a statistic, if a statistic actually for the two groups only. Then we have the further one more question we have. What is the purpose of the using a covariance matrix in a multivariate analysis? Any idea?
no, sir.
Covariance matrix is something like we'll be having x, y, x, and all. So actually, to determine the question, no, we are not going for the when we talk about the covariance matrix. So why will talk about the correlation, because both are different, is it?
Yes, sir.
To evaluate the variance of a single variable, no. In the covariance, we'll check with the variance. We'll check with the variable, but the thing it's going to be matrix is something they're going to be a summary. So to summarize the variances and covariances among the multiple variable. So third will be the answer. Is it? To evaluate the variance of a single variable, it's something like we have what you can say. What you can say, like it's a calculating the it's a
Multi.
process. It's not the matrix. Matrix is something combination of variance and
Yes.
covariance.
And correlation.
To perform the hypothesis, it's a test. So that can't be the matrix and all. So this can't be the answer. Is it clear? This one.
Yes, sir.
So covariance matrix is a key tool. Multivariate analysis is because it captures the both variance and relationship between the variable with that the variance. Diagonal element represent the variance of diagonal will going to represent the covariances. So it's something we are going to summarize. So now, I think now only we'll left out with the two more question or three more question. Then we'll wind up. Which of the following condition must be met the use for the F test for the food for two population variances? Just tell I have explained this one. F test. F test. It should be a both sample must be normally
It's
distributed. Is
only
it correct? Sample size
yes,
must
sir.
be equal. Not
Yes.
it's not going to be a necessary, is it?
Yes.
Not necessary. The sample must be paired. No. Why? Because we are not doing the paired t test. No, we are doing taking some sample. We are doing variance one. It can't be the pair case. So that's also not correct. It's actually for the paired t test. The population must be independent. Yes. Is it? But not necessary also, we
Yes,
can say.
sir. Uh,
So that the F test for two population variances is used to the whether two population have equal variance, but with comes with the strict assumption, normality, and then independence. Is it?
yes, sir.
Okay. Now we'll go with the what which statistic is used to measure the strength of relation between the two variable. Relation on which one? Linear. Which one? Covariance can't be.
Correlation.
Correlation will do. If a statistic again something different. T statistic no. Is it?
Yes, sir.
Measure the strength and direction of the linear relationship between the variables. Value range -1 to 1. Covariance it's indicate the variable move together. F statistic actually for the ANOVA. T statistic actually a hypothesis test. Is it?
Yes, sir.
Okay. We'll go one more question we have. What does a correlation coefficient of -1 indicate about the relation between the two variables? No. It means it should be of 0. Is it? Perfect negative -1, perfect positive +1, a weak negative, we can't say anything. So that will be the, is it?
Yes, sir.
Would be close to 0 but not negative. If two random variable is going to be an independent, what is the covariance between them? Independent. random variable. It means no variance. It means it's equal to 0. Is it? By the term itself, variance is something we are going to spread it out. Covariance measure how the two variables vary together. Now we have the last question. Which of the following are the true about the covariance? Covariance always going to be a plus minus 1 to plus 1. Covariance is a measure how variables change together. This can't be how. This also can't be, because we are not talking about the correlation only. Is it clear? Huh?
Yes, sir.
Shall we wind up?
Yes.
Any doubt is there?